Let's look at our final two identities using the sine function. We've seen that we can generate the sine function by taking the vertical height of our triangle and mapping it onto the respective angle. Now we can also generate the cosine function by taking the horizontal length of our triangle and again mapping it onto the respective angle. And you can see here we're generating the sine function and the cosine function. And in fact, if we were to look at the sine function, if we were to shift it to the left, it would sit directly on top of the cosine function. Or if we were to take the cosine function and shift it to the right, it would sit on top of the sine function. Now, we're not going to generate the identity here by shifting, we're generating the identity by a reflection. So let me show you what I mean by this. Let's take this back to, for example, 10 degrees, and we'll zoom in a little bit. Now if we were to take another angle, now this other angle here is going to be given by 90 minus the angle x. So in this instance we've got an angle of 10 degrees, which you can see down here. But now we're going to generate another angle, which is a larger angle, which is going to be the 90 minus the 10, which is an angle of 80 degrees. Let's see what happens whenever we do this. When we do this, the vertical distance in white here becomes the horizontal distance. And the horizontal distance in green here becomes the vertical distance on this one. So let's move it to another angle, and you can see that happening at, say for example, 20 degrees. Again, we've got the vertical distance becomes the horizontal, and the horizontal becomes the vertical. So in effect, the horizontal distance is going to be given by our cosine of our angle x, the vertical distance is given by the sine. But these get swapped over in this example here. The vertical then distance now becomes the same as the cosine, and then the horizontal distance for this becomes the same as the sine. So in effect, sine becomes cosine and cosine becomes the sine. So this gives us a relationship between the sine function and the cosine function. Now in order to go from this point here to this point here, what we do is we reflect this point in the line given by 45 degrees. So if we put this line in here, you can see that this point here gets reflected in this axis and it goes to this point here. So we're generating our identity that relates the sine and the cosine via a reflection. And in fact, the previous identities that we looked at for the sine function are all generated again by similar reflections. So our new identity is given as the sine of 90 minus x is equal to cos x. But this is just generated from the reflection of this point here over to this point here through the line given by 45 degrees. And we can see this being generated here. We're going to generate our final identity via reflection in the line given by 135 degrees. So previously we reflected in this line here at 45 degrees. So now we're going to use the 135 degrees. So if we take this back to, say for example, 10 degrees, then this point here is going to be reflected through this line down here somewhere. And you can see it's actually going to go down to this point. So now the vertical height here becomes the horizontal distance, and the horizontal distance here becomes the vertical distance. And we're going to map out this new function. So if I move this along through each of the angles, you can see that we're going to generate the reflection from here to this point here, and this generates this new function. Now, the new function we're going to get is going to be given by the minus cos theta. And if we zoom out here, we'll be able to see that. So you can see that the input function, if you like, is the sine theta. And what we get out through the identity is the function minus cos theta. Our new identity is the sine of 270 minus x is equal to minus cos x. And you can see that our previous identity was the sine of 90 minus x is equal to cos x. And we generated these via a reflection in the line at 45 degrees and a reflection in the line at 135 degrees. If we look at our table of identities from Wikipedia, we've now covered the first line here. So it's got 5 different identities, and you've seen that the last 2 were generated via reflections. So that's this one here and this one here. But in effect, the other 3 that we looked at were also generated via reflections. So this covers all of the identities that we're interested for sine. We can move on and we can look at the identities for cosine.